All right, so now we're looking for the trig functions of any angle. So if theta is in my standard position, and I could be anywhere, any quadrant, any number of times around the axis, and there's some point that's on my terminal side of my terminal side of the angle. So this xy could be anywhere on this line. If we continue going around, it's going to map out a circle. So we call this distance r for radius, because it could be a circle. And then if I think about creating a right triangle from this, I'm going to put this in pink. I could go down, straight down to the nearest x-axis, straight across to the origin. So notice here I've got my theta prime, which is my reference angle. And in this case, I'm going to say that so noticing this, we called this distance r. So we're going to say that sine of theta is the same as the ratio of sine theta is y over r. Cosine theta is x over r. This implies that this ratio is actually going to give us a negative value. Let's test that out a second, for example. And it tells me negative sine 24. Okay, well, 24 is my reference angle. Sorry, 24 is not my reference angle. Actually, my reference angle is 64, but notice that 90 minus 64 is 24, which is how sine and cosine are represented together. Let's instead do a control enter on that. But either way, we know we're going to get a negative value because it showed that we had a negative in front. So in quadrant 2, cosine values are negative, but the corresponding sine value, if I had, they've given me a sine, so I'll take it. So if we did sine of 114, I bet that your calculator, if I do it in exact mode, is going to tell me that it's the same as sine of 64. Remember, I just said the reference angle was 64. Oh, Lord. Ah, and now it tells me cosine of 24. Your calculator is so funny. But if I control enter that to find an approximate value, we get 0.91 as our ratio. And notice that makes sense because I said 114 degrees, which would be up here. So my opposite side would be nearly as long as the adjacent side. All right, so here we've got 3 trig ratios. Well, this says to find 6. The other 3 are the reciprocals of these. So we've got that the reciprocal of sine, it's easier to see the opposite side. That's going to be r over y. We call that the cosecant of theta. So reciprocal of sine is the cosecant. And I did not come up with these names myself. It's a bit annoying because now I'm going to tell you the reciprocal of cosine is the secant. And that's going to be r over x. The nice one here, the reciprocal of tan, is the cotan, and it is x over y. So there's my 6 functions. X and y can be 0, positive, or negative. R, so let me state that over here. X and y are an element of real numbers. So they could be 0, positive, or negative. R, though, is defined as the hypotenuse or the radius, and r is always greater than 0. I can also rewrite r using Pythagorean theorem. X squared plus y squared is r squared. All right, let's put that into action. So notice, depending on the quadrant, that's going to determine what is positive and what is negative. So in quadrant 1, I know that x and y are both greater than 0. That means that my sine ratio, again, sine is y over r. Oh goodness, sine of an angle is y over r, which will be positive. Cosine will be x over r, which is negative. Tangent will be y over x. Oh my gosh, why did I say negative? X is positive. Sorry, x over r is positive. Y over x is also positive. In quadrant 2, x is negative, y is positive. So sine theta, being y over r, will be positive. In quadrant 2, this is what we just discussed, cosine of theta, x over r, that one is negative. Tangent, positive over negative is negative. Quadrant 3 angles, well, in quadrant 3, x and y are both negative. So sine theta will be negative. Cosine theta will also be negative. But now tan theta, negative over negative, is positive. Quadrant 4, x is positive, y is negative. So now my opposite side is negative. So sine theta less than 0. Cos theta greater than 0, adjacent is positive. Tan theta is negative over positive, less than 0.